Good afternoon and welcome back to the Workbench. Today I'm doing a quick little video on why cheap electronic components are not always as good value as they seem to be, and why this little resistor here, which otherwise looks perfectly ordinary, gave a very annoying and strange fault with my recently built Hakko knockoff T12 soldering station. And we'll see, I'll talk about that in a minute. But that is the culprit there. This one looks perfectly normal, looks perfectly fine. It's 470 ohms, it measures 470 ohms. You would think there's absolutely nothing wrong with it. But you'd be wrong. I'll show you why in just a second. So these are some cheap resistors I bought off eBay a long time ago, maybe 2-3 years ago, I can't remember exactly. I think it was about a US $1 or $1.50 or something ridiculously cheap for, say, I don't know, 100 or 200 of them. I'm not sure exactly how many. I can't remember, but it was a lot for very low cost. And normally I do have stock of most resistor values because I did manage to get a pretty much complete set from a local Dick Smith that closed down when they all exited electronics and closed down and went bankrupt and went online after they got bought out by some other guy. But anyway, I got a lot of stuff from there, but of course the common values like this, 470 ohm or 10k, 100k, the kind of stuff that gets used a lot, there was either low stock of those or not any stock left whatsoever. And 470 ohm was something that I completely ran out of very quickly. I probably only got like 5 or so in that bulk lot that I did buy, so I didn't have many at all. And I bought these on eBay because I thought, hey, they're really cheap and why not? They look fine and I don't really see how they could be a problem. I thought, manufacturing has improved in quality. These are not like the old carbon composition resistors from the 70s or something. These are, metal film. It's all pretty precise stuff, and it's not too hard to manufacture these days. Even the cheap ones should be okay. And really, in terms of actual value, these are 1% resistors or something. They are actually pretty good. They are all in spec as far as I can see, all the ones I've used so far, and the leads are still shiny. They haven't gone oxidized over time, although I have kept them in this bag, so that probably helps. But overall they did seem quite good quality. But recently, after this one here gave me a big headache, I have once more returned to my own saying, my own little thing that I've come up with over the years, and that is that cheap parts on eBay or AliExpress or whatever budget stuff from bargain basement sellers direct from China, basically what I've learnt so far is that in most cases, or almost all cases, or in fact every case, when you buy something that cheap, there's always something wrong with it, even if you don't immediately understand what that is. And it usually becomes apparent over time what the problem is if it's not apparent straight away. And in the case of these resistors, at first they seemed perfectly fine. Like I said, the value was perfectly in spec. They haven't gone rusty, they haven't fallen apart, everything seems to be just fine. Admittedly, the leads are quite thin, they're not as thick as the Dick Smith resistors, they're probably about half the thickness, so yeah, there's that, but hey, it's not a huge deal. But recently, this one proved to me exactly what the problem is with these, and I'll do a very nice close-up of this resistor and show you exactly what the problem is. But first I'll talk about the fault. What I have in this soldering station, and it's just off screen there, so if you've seen the previous video you know what I'm talking about. But basically, you have temperature detection for the tip. The tip in this case has a heater inbuilt, and the heater is in fact the thermocouple as well. It's made of two dissimilar metals. It has a voltage that it can generate when different temperatures are applied, so whatever the temperature is of it, it will have a different voltage output. And if you measure that voltage, amplify it with a little op-amp, you can read that with the analog input of a microcontroller, and you can convert that to an actual temperature reading, and then the soldering iron knows how hot the tip is. That's the idea. So what we have is we have our little op-amp. You got our output. I won't draw the inputs or the voltages or anything, but we have this. This comes out, and we have the resistor, in this case that one there. So that's 470 ohms, and that goes out to, we got the big microcontroller. Let's just see. Put this down, hopefully you can see that alright. So anyway, we got this output here. It goes through this current limiting resistor, goes to the input of the ADC here. Sorry, I'm drawing this quite badly, but oh well. Goes to the input of the ADC, and this is just to limit the current, I guess, in case something funny goes on. Now, this is basically the entire circuit. There is an output here from this chip going through this resistor to the input of this chip. There is no other external component, there's no connection to anything else. The output of this should be practically exactly the same as the input to here. No external influence caused whatsoever. But you see, the problem with the soldering station I had was that I ran it for about an hour. I finally put it all together. I got it built into the case. Everything was fine. I ran it for about an hour, putting together another project, which was a electronic load project. In fact, that's over here. This project there. It's still not 100% finished. It's still missing the power socket, which has to turn up. I ended up having to do the same thing with this. Ran out of space, had to get one of those cloverleaf ones. Hadn't intended to do that, but there we go. That's that there. So I was soldering all this together, and we can see actually, there's quite a bit of stuff in here. Quite a bit of things. Quite a lot of parts. So I was doing, quite a bit of soldering on this thing, and the soldering iron seemed to be perfectly fine. It ran for, I don't know, about an hour or something, and suddenly the temperature display, it was sitting around 350 degrees, what I'd set it to. It was varying up and down a little bit, as you'd expect, but otherwise it was working perfectly normally. And after about an hour of use, suddenly the temperature display just went to 533, started bouncing around 533, up and down, maybe 530, eventually settled on 533, and then the thing just stopped working. I was able to change the temperature. I was able to go through the presets, go into the menu and all that, but the displayed temperature was 533 degrees, and of course that just instantly turned the tip off, and the tip just went cold because there was no power going to it, because the microcontroller assumed that the tip was in fact at 533 degrees, which it wasn't. That was about a bunch of lies. And I was very confused as to what could have gone on. And I tested the handle. I got the tip, I got the handle. I checked the connections. I took the tip out of the thing, and I checked, had the heater gone open circuit or something? What was going on? That was fine. I checked all the wiring between the handle to the plug. I checked the plug, and everything to the board. Everything was perfectly fine. And I thought, this doesn't make much sense. So I figured, well, the first thing I thought of, well, this op amp here, maybe the op amp has gone faulty or something. It's got a short on the output or something. Or maybe the input to the ADC has gone bad. Maybe the PIC has got some problem. Maybe it's a firmware bug. I don't know. Because, like I said, there's only like two basic things. There's just these two components here. I mean, if either the output of this is wrong, or the input of this is wrong, but the input of this can't be wrong because it's only connected to this. There's nothing else here except for this resistor, and a resistor wouldn't be bad, would it? Well, anyway, I looked at the circuit to do with this op amp, and I thought, okay. I checked the inputs. The inputs all made sense. Nothing seemed to be wrong there. I checked the supply. It was getting the correct supply, 5 volts. Everything was correct. Ground was correct. All the inputs were okay. And I actually checked the point at this node here. So this output here was in fact, I think at the time it was something like 0.5 volts. And that was, a fairly sensible reading. Considering what it was doing, and I thought, well, there's obviously nothing wrong with that. I mean, this is outputting a low voltage because it's reading a cold tip that has no power applied to it. And I mean, the way this works, obviously, the higher the the higher the temperature at the tip, the higher the voltage output from the tip, and this amplifies this, so the higher the voltage output here. So with a low voltage like this, 0.5 volts or whatever it was, I forget exactly, but it was quite low, and it made perfect sense. It was logical value. And then I measured over here at this point here, and I got, what did I get? I think I got 4.96 volts or something ridiculous over here. And I thought, what? You know, I was like, hang on, if this op amp is outputting 0.5 volts or something very low, and now I'm getting 5 volts here, where is this possibly coming from? I mean, we've only got these two components. Well, we've got this here in the middle, but that's just a resistor. Resistor can't generate voltage, right? Impossible. So if the op amp is outputting 0.5 volts, the op amp must be fine. It seems to be doing what it's doing. So the input to this ADC pin is now 5 volts. So maybe the microcontroller has internally shorted. Maybe there's a short between the rail and the input pin, and somehow, or maybe the firmware is locked up and it's set the ADC input to an output and it's pulling it high. And I thought, you know, that's very, very odd. And of course this firmware that I'm using is not my firmware. I didn't write it. It's just the firmware that the person who did this project before me, just copied this and made modifications to it. I thought, well, you know, I mean, maybe his firmware is bad, maybe there's a bug in it, maybe there's some issue, I don't know. It could be a problem. Maybe I didn't program it right, maybe there's some issue, I don't know, some obscure thing. But I mean, thinking about this, that's too obscure, that's kind of strange. So I thought, well, you know, what's the most logical thing? The logical thing is, we do have a trace running between here, and this is something I've seen before. And I figure, you know, but somewhere between this resistor and this pin here, I got to have like a solder short somewhere between this trace and between another trace. You know, there's got to be like just a whisker of solder that's bridging this track to another track. I mean, that's a pretty common thing, especially if you do your own boards, you solder it yourself. I did the whole board myself, you know, tinned it myself, everything. So there is a chance for error there. There's no solder mask. A solder spike bridging two tracks or something is a possibility, or a solder ball has fallen on there or something, you know, who knows, or a piece of wire even has got stuck to it, I don't know, you know, like a very thin strand from a multi-strand multi-core wire or something. And I looked at the track, and I looked at it very closely, and I got my little magnifying loop thing out, and I gave a very good close-up look, and there was absolutely nothing wrong with the trace whatsoever. The trace was perfectly clean. It had very, you know, all the clearance between the trace and other traces. I mean, the other thing was there were no 5 volt traces running next to it. It was all just other signals or ground or whatever. There was just basically nothing there. And there were no bridges, no solder balls, no nothing. And yet I was still getting almost 5 volts at this point and almost 0 volts here. And there was 5 volts coming from somewhere that wasn't, you know, it didn't make any sense. And I thought, where can 5 volts be coming from? I'm getting 5 volts out of thin air, basically. So I kind of thought, well, you know, the microcontroller has got to be bad. It's got to have internally shorted. I mean, that doesn't often happen, but it could happen. It's possible. Maybe it got damaged. I mean, I've got an anti-static set up. This matter's all anti-static. It's all grounded. I did all the work on that. I mean, it's unlikely that I caused some ESD problem to the microcontroller, but hey, you know, it is plausible. That is a thing that happens. I could have somehow damaged it, or maybe I accidentally shorted this pin to something while I was building it or testing it and I didn't notice, or something like that. You know, it's possible. It happens. We all make mistakes. It could be that I just broke the microcontroller, and it worked for an hour, and then it finally gave up and just went shorted and died. You know, it's plausible. That can happen. And I was just about to go and order another one and you know, swap it out and think, well, you know, it seems like the only logical thing because the op amp seems perfectly fine. Can't see a problem there. It just seems to be on the this node here between this resistor and this. And then I looked at the board. I opened the soldering iron and I looked at the board again, and I thought, hang on, can't be, can it? It can't be. But I looked up here, as you can see on the board, and I looked at where the trace actually ran, and I looked at where the resistor went, and I looked at the layout I'd done on the board, and I remembered that I'd run this wire link beneath these two resistors here, and these two resistors are in fact outputs from the dual op amp. And both of them run across the top of this bare piece of wire, and yeah, that seems a bit kind of silly, but hey, you know, the resistor is touching the wire with the resistor body. The resistor body is covered in paint. The paint is non-conductive. There shouldn't be an issue, right? I mean, I've done things like this before in the past, running wire links under components and stuff, and you know, I haven't really had a problem with it. In fact, I've never had a problem with it. Usually it's obviously a good idea to use insulated wire or something, and in most cases I do. But I have definitely run uninsulated wire links behind other components, and because the bodies are plastic or ceramic or whatever, you know, it's an insulator, there's no real issue. It never has been a problem. But I looked at this resistor, and there's two resistors, and the one on the right hand side, the wire link runs very close to the end of the resistor, not on the lead, not anywhere near the lead. It's, you know, 2 millimeters away from it at least, and you know, there's no way that's going to be a problem. But I thought, that can't be right. Can that possibly be this resistor has shorted to that wire? And I thought, no. And then I pulled it out and I looked at it, and I thought, it actually has. So I got the resistor and I took it out of the circuit. I took it off the board and I had a good look at it. I looked at it very closely, and I discovered something that made me go, that's why these were so cheap. That's what's wrong with them. That's the hidden defect that you only figure out 3 years later. That is what's wrong with these things. And I'll just show a close-up of this so you can see, and maybe you can see for yourself, what the problem is. The body of this resistor, the paint, is just not met the edge of that end cap. Right on the top there, right where the reflection of my lights is, you can just see bare metal just poking through on that sharp edge of that end cap, just between the brown and the black bands. And it's just thin enough that the glaze or the paint or whatever it is just barely came off that sharp edge, and you can just touch the metal of the end cap underneath it. And so my little wire link, my uninsulated wire link, which is kind of my own fault, but I didn't expect this, was shorting out just on the edge, just right on the edge of that sharp point where the paint was just thin enough, and it was able to short that end cap of the resistor to the 5-volt rail. And so there we go. So this node here was in fact shorted through the end of this resistor to my wire link to the 5-volt rail. It was shorted here, so we had 470 ohms still between the op amp and the rest of the resistor here. So the op amp was basically sinking about 10 milliamps through this resistor. So it was perfectly fine. The output's rated for 30 milliamps maximum, so you know, it's not an issue. It could happily do that all day, but of course the low voltage that it was trying to output was not getting its way through to the ADC input. The ADC was effectively shorted to 5 volts through this here, and so for all the microcontroller knew is that the output of this was very high, was that the tip was very hot, that it was apparently at 533 degrees, and that's why it was reading that value, and it was saying, well, we've got to turn the iron off because it's too hot. And so the iron just went cold, so even though there was no power going to it whatsoever, this was getting confused. So this is the first time I've seen something this strange. I mean, it's not very strange at all when you think about it. It's perfectly logical. It's my fault, A, for running an uninsulated link underneath the component and relying on the component's body to provide insulation. That's bad practice. So I have myself to blame for that, but at the same time, these resistors are not manufactured properly. They have a very thin coating of paint or glaze or whatever it is, and it's clear that that was also the other part of the problem. So definitely worth noting if you do buy cheap components. Be on the lookout that funny things aren't going to happen with them, because there's very often something funny with them. That's why they're so cheap. I mean, 100 resistors, 200 resistors, whatever it was, for $1 or something. That's a pretty good value, but yeah, sometimes it's better to buy the good quality ones from DigiKey or Mouser or Farnell or Element 14 or RS Components or anywhere other than eBay. I mean, if you're really desperate, if you can't afford to buy those ones, you know, if $1 for 100 of them off eBay is all you can get, well, yeah, I guess it's fine, but just be aware that you could have issues with them. And yeah, that's just a thing. But that's just interesting as a fault. Very strange, and well, it makes perfect sense once you understand what happened. But before that, it's kind of like, how very odd. It was either a shorted micro or a bad firmware that I thought it was, but turned out to be a shorted resistor. Well, not really a shorted resistor, but a leaky resistor, possibly. An uninsulated leaky resistor. But anyway, that's that. So there we go. The perils of cheap components and the perils of doing silly things with your board layout. Yes, I have myself to blame in part for that. I should have really put an insulated wire link, and I did in fact fix the problem later on by putting the resistors a bit higher than the board, and then I put some tape over the top of the link, so everything's insulated now, and now the soldering iron works perfectly without any issue. So there we go. That's that one. The perils of cheap components, or the perils of being silly with them. Put them both together and you give yourself a giant headache and wonder what the heck's going on. But anyway, hope that was interesting. Hope that was useful. See you next time.